Chapter 5. Getting started with Python. Introduction. What is a programming language and how it works? An ordered set of instructions to be executed by a computer to carry out a specific task is called a program, and the language used to specify this set of instructions to the computer is called a programming language. As we know that computers understand the language of zeros and ones, which is called machine language or low-level language. However, it is difficult for humans to write or comprehend instructions using zeros and ones. This led to the advent of high-level programming languages like Python, C, Visual Basic, PHP, Java that are easier to manage by humans but are not directly understood by the computer. A program written in a high-level language is called source code. Translators like compilers and interpreters are needed to translate the source code into machine language. Python uses an interpreter to convert its instructions into machine language, so that it can be understood by the computer. An interpreter processes the program statements one by one, first translating and then executing. This process is continued until an error is encountered or the whole program is executed successfully. In both the cases, program execution will stop. On the contrary, a compiler translates the entire source code, as a whole, into the object code. After scanning the whole program, it generates error messages, if any. Features of Python. Python is a high-level language. It is a free and open-source language. It is an interpreted language, as Python programs are executed by an interpreter. Python programs are easy to understand as they have a clearly defined syntax and relatively simple structure. Python is case-sensitive. For example, uppercase number and lowercase number are not same in Python. Python is portable and platform independent, means it can run on various operating systems and hardware platforms. Python has a rich library of predefined functions. Python is also helpful in web development. Many popular web services and applications are built using Python. Python uses indentation for blocks and nested blocks. Working with Python. To write and run a Python program, we need to have a Python interpreter installed on our computer, or we can use any online Python interpreter. The interpreter is also called Python shell. A sample screen of Python interpreter is shown in figure in the below screen. The symbol is the Python prompt, which indicates that the interpreter is ready to take instructions. We can type commands or statements on this prompt to execute them using a Python interpreter. There are two ways to use the Python interpreter: interactive mode and script mode. Interactive mode allows execution of individual statement instantaneously, whereas script mode allows us to write more than one instruction in a file called Python source code file that can be executed. Interactive mode. To work in the interactive mode, we can simply type a Python statement on the prompt directly. As soon as we press enter, the interpreter executes the statement and displays the results, as shown in figure. In the script mode, we can write a Python program in a file, save it and then use the interpreter to execute it. Python scripts are saved as files where file name has extension .py. By default, the Python scripts are saved in the Python installation folder. To execute a script, we can either type the file name along with the path at the prompt. For example, if the name of the file is prog5-1.py, we type prog5-1.py. We can otherwise open the program directly from IDLE as shown in figure 5.3. While working in the script mode, after saving the file, click Run and then Run module from the menu as shown in figure 5.4. The output appears on shell as shown in figure. Python keywords. Keywords are reserved words. Each keyword has a specific meaning to the Python interpreter, and we can use a keyword in our program only for the purpose for which it has been defined. As Python is case sensitive, keywords must be written exactly as given in table. Identifiers. In programming languages, identifiers are names used to identify a variable, function, or other entities in a program. The rules for naming an identifier in Python are as follows. The name should begin with an uppercase or a lowercase alphabet or an underscore sign. This may be followed by any combination of characters like lowercase a to z, uppercase a to z, 0 to 9 or underscore. Thus, an identifier cannot start with a digit. It can be of any length. It should not be a keyword, a reserved word given in table 5.1. We cannot use special symbols like @ hash, $, %, etc. in identifiers. For example, to find the average of marks obtained by a student in 3 subjects, we can choose the identifiers as marks 1, marks 2, marks 3 and AVG rather than A, B, C. Average is equal to marks 1 plus marks 2 plus marks 3 by 3. Variables. A variable in a program is uniquely identified by a name. Variable in Python refers to an object, an item or element that is stored in the memory. Value of a variable can be a string example, B global citizen, numeric example, 345 or any combination of alphanumeric characters like CD67. In Python we can use an assignment statement to create new variables and assign specific values to them. In the program 5.2, the variable message holds string type value and so its content is assigned within double quotes, can also be within single quotes. Whereas the value of variable user number is not enclosed in quotes as it is a numeric value. Variable declaration is implicit in Python, means variables are automatically declared and defined when they are assigned a value the first time. Variables must always be assigned values before they are used in expressions, as otherwise it will lead to an error in the program. Wherever a variable name occurs in an expression, the interpreter replaces it with the value of that particular variable. Comments. Comments are used to add a remark or a note in the source code. Comments are not executed by interpreter. They are added with the purpose of making the source code easier for humans to understand. They are used primarily to document the meaning and purpose of source code and its input and output requirements, so that we can remember later how it functions and how to use it. For large and complex software, it may require programmers to work in teams, and sometimes a program written by one programmer is required to be used or maintained by another programmer. In such situations, documentations in the form of comments are needed to understand the working of the program. In Python, a comment starts with hash sign. Everything following the hash till the end of that line is treated as a comment and the interpreter simply ignores it while executing the statement. Everything is an object. Python treats every value or data item, whether numeric, string, or other type, as an object in the sense that it can be assigned to some variable or can be passed to a function as an argument. Every object in Python is assigned a unique identity which remains the same for the lifetime of that object. This ID is akin to the memory address of the object. The function ID returns the identity of an object. Data types. Every value belongs to a specific data type in Python. Data type identifies the type of data values a variable can hold and the operations that can be performed on that data. Figure 5.6 enlists the data types available in Python. Number data type stores numerical values only. It is further classified into 3 different types: int, float and complex. Boolean data type is a subtype of integer. It is a unique data type consisting of 2 constants, true and false. Boolean true value is non-zero, non-null and non-empty. Boolean false is the value 0. Let us now try to execute few statements in interactive mode to determine the data type of the variable using built-in function type. Variables. Variables of simple data types like integers, float, boolean, etc. hold single values. But such variables are not useful to hold a long list of information, for example, names of the months in a year, names of students in a class, names and numbers in a phone book, or the list of artifacts in a museum. For this, Python provides data types like tuples, lists, dictionaries, and sets. Sequence. A Python sequence is an ordered collection of items, where each item is indexed by an integer. The three types of sequence data types available in Python are strings, lists, and tuples. We will learn about each of them in detail in later chapters. A brief introduction to these data types is as follows. String. String is a group of characters. These characters may be alphabets, digits, or special characters including spaces. String values are enclosed either in single quotation marks example, hello, or in double quotation marks example, hello. The quotes are not a part of the string, they are used to mark the beginning and end of the string for the interpreter. For example, str1 is equal to hello friend, str2 is equal to 452. List. List is a sequence of items separated by commas and the items are enclosed in square brackets. Example 5.4. To create a list. List 1 is equal to 5, 3.4, New Delhi 20C, 45. Print the elements of the list, list 1. Print, list 1. Output is 5, 3.4, New Delhi 20C, 45. Tuple. Tuple is a sequence of items separated by commas and items are enclosed in parentheses. This is unlike list, where values are enclosed in brackets. Once created, we cannot change the tuple. Example 5.5. Create a tuple. Tuple 1. Tuple 1 equals 10, 20, apple 3.4, a. Print the elements of the tuple. Tuple 1. Print, tuple 1. 10, 20, apple 3.4, a. Set. Set is an unordered collection of items separated by commas and the items are enclosed in curly brackets. A set is similar to list, except that it cannot have duplicate entries. Once created, elements of a set cannot be changed. Example 5.6. Create a set. Set 1 equals 10, 20, 3.14, New Delhi. Print, type, set 1. The output is class, set. Print, set 1. The output is 10, 20, 3.14, New Delhi. Duplicate elements are not included in set. Set 2 equals 1, 2, 1, 3. Print, set 2. The output is 1, 2, 3. None. None is a special data type with a single value. It is used to signify the absence of value in a situation. None supports no special operations, and it is neither same as false nor zero. Example 5.7. My var equals none. Print, type, my var. The output is class, none type. Print, my var. The output is none. Mapping. Mapping is an unordered data type in Python. Currently, there is only one standard mapping data type in Python called dictionary. Dictionary. Dictionary in Python holds data items in key-value pairs. Items in a dictionary are enclosed in curly brackets. Dictionaries permit faster access to data. Every key is separated from its value using a colon sign. The key-value pairs of a dictionary can be accessed using the key. The keys are usually strings and their values can be any data type. In order to access any value in the dictionary, we have to specify its key in square brackets. Example. Create a dictionary. Dict1 equals fruit, apple. Climate, cold, price, kilogram, 120. Print, dict1. The output is fruit, apple. Climate, cold. Price, kilogram, 120. Print, dict1. Price, kilogram. The output is 120.